All right, so with our bell ringer here, we have to use the distributive property to solve. So once I've distributed that 7 to the D and to that 5 by multiplication, this is what I should have there. 7D plus 35 equals 68. So now we need to solve for D. We need to find out what number D is representing. Guys, what's my first step in getting that D alone? Tyler? Not yet. Can't divide this yet. I got to get rid of somebody else living in the house. Owen? I got to subtract that 35. I've got to subtract that 35. And because this is an equation, whatever I do on that left side, I've got to do the exact same thing on the right side. We want to keep both sides balanced. So, our 35s have now left 7D's house. Okay, and 68 minus 35. Could you work that out for me? That's pretty simple subtraction. Juvenile? 33. Very good. Now, what do we do to get that D alone? Divide. Hey, Mivak, why am I dividing here? What's happening between the 7 and the D right now? They're being multiplied. And the opposite of multiplication is division. So, to isolate our variable here, we're going to divide by 7. And remember, we have an equation. So whatever operation I do on the left side, I have to do the same thing on the right side. Okay? So we'll use our calculator here. $33 divided by 7, 4.71. Remember, when we have a decimal answer, we always go to the hundredths place. Okay? 4.71 is what D would equal. All right, so we're going right into our lesson today. If we look at our objective for today, I can, that means you, combine like terms to solve an equation. I can combine like terms to solve an equation. But what in the world is a like term? Okay, so in our notes, we're going to write combining like terms. And some of us may have already done some of this in our Math Nation lessons, but I wanted to make sure everyone is on the same page to perfecting, mastering this skill. Let's look at this. 7y plus 2 plus y. Do these two terms look alike? No. So can I add them together? We want to remember, star statement, we cannot add or subtract unlike terms. Are 7y and y, are those like terms? Yes. So if we are to combine these like terms here, I'm going to underline my like terms. You should too. What number is always in front of our variable? Michael? There's a 1 there. So, Casey, what's 7 plus 1? Very good. We're going to have our 8y plus 2. That 2 stays the same because it couldn't be added to anything. It was an unlike term. Example 1. 8a plus 2a minus a plus 7. How would I simplify this expression? Those are the directions that you'll usually see. How do I simplify this expression? So, following our same strategy, I'm going to underline my like terms. Those are the ones I can add or subtract together. What operation will I perform between the 8 and the 2 here? Adding. Now, my 5th period struggled with this yesterday, and I want to see if you guys will. What operation will I perform here with that A? Subtract. Some of them didn't know which one to do. The sign is there. So, what is 8 plus 2?
10.
And what is 10 minus 1? 9a plus 7. That's how we would simplify this expression. Example 2. Let's simplify this expression. Going back to our bell ringer here, if you need the notes, they're here up front. Going back to our bell ringer here, what property will I be using here? Yeah, I'm going to be distributing that 7 to both terms inside my parentheses. Remember, we're multiplying here. Good. 7 times A, what would that look like?
7.
Owen? Yeah, 7A. And what is 7 times 2? 7 times 6, sorry. 42. Minus 2A. Now, I'm going to underline my like terms. And Casey, what am I doing between this set with this 7 and this 2? What sign is it telling me to do? Subtract. So 7A minus 2A is what, guys? 5A plus 42. That's our answer in simplest form. Let's do one more example with the distributive property. And Miss Neville's going to walk around to see how you're doing with it. It is not a good idea to just sit there and let Miss Neville and wait for Miss Neville to do the work. Eight times 2D plus D plus 15. Let's start working this out now. All right, my dears, looking good. So let's look here. We're going to multiply that 8 times that 2D, and we're going to multiply that 8 times that D. Did anyone add these together and then multiply? Yeah, I saw that. Taylor, very good. Evan. So what I could have done, let's do 2 arrows here. There's 2 ways you could have done this. Both ways are correct. It's up to you, really. What I could have done here is added those two together and gotten 3D. And I would have gotten 24D plus 15. Remember, whenever I see those parentheses, that tells me to multiply. Or you could have done it this way. You could have done 16D plus 8D plus 15. 16 plus 8, 24. And I could have gotten my answer that way. Either way you did it, one of these ways, good job, correct. All right, so as we move into our independent practice today, you're going to be getting a sheet that Ms. Neville's going to show you how to work through today. All right, the first thing I should have done is put my name on this paper. I'm going to zoom in so you can see what I'm doing. I'm working on the left side today. On your paper, if you would please write Tuesday here. And we're going to write Wednesday over here. Tuesday on the left side. Wednesday on the right side. And I'm writing my name here, as you should have done, and today's date. So we're just working on this side today. Ms. Neville's going to do this one with you, and I'm also going to do the distributive property one with you. And then you're going to do these 4 on your own. So let's look at our first one here. $3M plus 4 plus 6M. You want to remember your strategy. You want to underline the like terms. And Casey, what am I doing with 3M and 6? Am I subtracting, adding, multiplying, or dividing? Baby, what sign is there? Adding. That's what it tells me to do. And what is 3 plus 6, guys? 9M plus 4. The sign here tells us what to do between those two terms. We're going to scroll down here to this one. Remember, we're distributing our 7 to the x and our 7 to the 2. We're multiplying that 7 to the x. We're multiplying that 7 to the 2. What is 7 times x, guys? Juvenile, what's 7 times x? 7x, very good. Tyler, what's 7 times 2? 14. Kept that addition sign there. It didn't go anywhere. Minus 6x, because he was not inside the parentheses. I'm then going to underline my like terms. Casey, one more time. What am I doing with the 7 and 6x? Subtracting. Yep, that's my sign there. And what is 7 minus 6, Madison? So could I just write x plus 14? It is not the end of the world if you want to put a 1 in front of these as you're learning about the value of a variable. It's not the end of the world there. Okay? All right, let's get to work on these 4. You may come see Miss Neville if you need help.